Sorry for the interesting opening. So I'm Thomas, and this is Helen, and we are going to talk to you today about what it is to scale your Android team from 7 to 70 developers, and how to scale your app release in the process. There was a lot of technical conversations today, a lot of like awesome in-depth technical talks. Ours is going to be a little bit more about organization and basically how to organize your team to make sure that you're still performant, you still manage to be productive as your team and your application grow. So we are both from LYFT. So what is LYFT? LYFT is the second ride-sharing platform in North America. Our mission is to improve people's lives with the world's best transportation. And we are a car sharing or a ride hailing solution with cars, but we also have a pretty dense network of bike sharing applications too. We're actually gonna touch on that a little bit later during the talk. And we are only based in North America, so Canada and the US for now. All right, Helen.
And hi, my name is Helen. I am a technical program manager here at LYFT, and specifically on the release team. I'm gonna give you a little intro of what a release manager does here at LYFT. We're ultimately the owner of the release build. What changes occur on the build after we've cut a release, including being the mobile leader and driving strategy for the mobile org, which includes things like code freezes, schedule maintenance, and ultimately the second goal that a release manager here has is to build process to help make sure that we build governance systems that allows us to scale efficiently.
And this is me. So I'm an Android engineer. I'm not gonna have to explain what it is. And I'm currently in the acquisition engineering team. So our goal is to basically increase the audience of drivers and riders. And so most of the features that I'm developing and ship are basically aiming to do that. And I'm based in Seattle on the Pacific Northwest, so next to the border with Canada. But I'm originally French, as you can probably tell with the accent, if I still have it. Great. So let's go back a little bit in time. So we are in 2015, second quarter, and LYFT at the time is 700 engineers, and I joined the team as the 8th Android engineer. So 800 developers, it's actually a pretty decent size already for a team. That was actually the biggest team I've ever been part of. So at the time, we are still kind of like the Android team, although pretty soon after I joined, we are kind of like dispatched into different cross-functional teams. So I joined the passenger team. At the time, we basically had a rider and a passenger team and a few people working on like pure framework stuff and architecture things. But yeah, that was pretty straightforward when it comes to the team organization. But one thing that we kind of like run into after a while is the fact that basically we have this kind of tribal knowledge of what is the right way to do this or what is the right way to do that. Like, how do we access data? How do we store data? How do we display them on the screen? But most of that is mainly kind of like guidelines, and we don't really have like a very clear structure on the right approach and kind of like a fixed framework for the right approach to display things on the screen or literally build feature. And so what happens is that everybody is kind of like building features the way they always did. And so it kind of like goes well for a while, but after a while, you kind of have to start to add some structure to that. And so in 2015, later in 2015, we start to work on Scoop. So Scoop is basically our internal UI framework, and it's It comes at a time. So remember, we are in late 2015. So there was still the debate between activity and fragment that is raging at the time. And you see more and more people kind of like going with the approach of view only or like single activity architecture. There was Flow and Mortar that is built by the people at Square at the time. There are a few people who are looking into similar things. So Scoop is basically our answer to this problem. And we kind of like start to embrace it internally. And after a few months cleaning up the project and making it available for everybody, we decide to open source it.
Throughout today, you'll hear Thomas focus a lot more on tools and architecture changes that occurred during this time, and I'm going to focus way more on our release process. So I wanted to go over some of the release vocab that you'll hear me use throughout so that you don't get too confused. We determine a cherry pick based on any code that's merged into a release branch after we have cut that release branch, which for us is anytime after a Wednesday morning. A late merge is a code that is shipped after we've already cut the beta and we've already actually started testing. A hotfix is anything that goes on after we've released an app to production. Our golden path is essentially anything in our core user experience. This means a rider's ability to take and pay for a ride and a driver's ability to actually get that ride and get paid for it. A release blocker is any issue or event that's serious enough to warrant canceling or skipping. Our team is now on a weekly cadence, so we try very hard to stick to a consistent format. So during this time at LYFT, we had a very flat mobile organization. We had one app that allowed you to switch between two profiles, one as a rider and one as a driver. We had very little process and many ad hoc planning. We were just trying to get our features out as quickly as possible. Our releases were inconsistent and there was truly no oversight. We really just wanted to make sure that we got everything in as quickly as possible. And even as we work, we started having exceptions to the rules that started showing a crack in our process.
So fast forward 1 year. So we are now in 2016, and it's already the team is already twice the size as what it was when I joined a year before. And so that's pretty interesting because when you reach that size, you kind of like realize that a lot more code gets committed into the application. And so we have this kind of like UI approach, as I talked about, we are using Scoop. So when it comes to the architecture and the organization of the view and the screen, I think we are pretty much set at that point. One issue we are running into though is that the compilation time of the application takes a lot of time. And so to basically fix this problem, we decide to switch our build system and stop using Gradle, which I was going to say was, but it's still today the main build system for Android. And we decide to embrace Buck. So some of you might know Buck already, but if you don't, it's basically the internal build system that is used at Facebook. So they kind of like, as we did for Scoop, basically they kind of like build it for themselves initially. They are obviously way bigger. They were already way bigger than we were, but they are still today way bigger than we are. I don't know how many people commit on their code base on a release basis, but it's definitely more than our size today. And they tend to have a similar approach to ours, which is having a single repo where basically all the code of the Android app goes, as far as I know. That might have changed, but at the time that was the case. So they basically had to have a build system way more advanced and way more robust than what Gradle was offering at the time. And so we kind of like switched to Buck to basically solve the same issues that we had. So Buck provides incremental compilation, build prioritization, and also a pretty advanced local and distributed caching management. And you might hear all those things today and you might think, wait, but I thought Gradle is also doing those things. And that's true. Today, I think Gradle is doing a decent job at this, but that was definitely not the time in 2016. And so at the time, we embraced the heavy modularization of every single part of the application. So that was literally every new module, every new feature that we added was pretty much a new module, and that's still very much the case today. And so we had to have a pretty advanced build system to basically handle it. So we switched to Buck. And as an example, and I think it's just like to give you an idea of the build time, although I'm pretty sure that those numbers come from a benchmark on a pretty beefy machine, and I don't think a regular developer laptop was building the application as fast at the time. But you can see that we basically had a 3-time increase of the build time for switching from Gradle to Buck. And the incremental builds was literally from like a minute or a couple of minutes to a few seconds. So that was a huge improvement for us, and that basically enabled us to keep scaling the size of the team and also the size of the code base. So that's basically the kind of like architecture and CI part of the world. But what is interesting is that LYFT at the time and today, I think we would say, even if we are way bigger than we were at the time, we're still pretty much a startup. And being part of a growth team, that's still something that speaks and resonates to me very much still today. And I guess if you haven't read Eric Ries's Lean Startup book, I really recommend it. It gives you a good idea of what basically means to kind of like work at a startup, or what does it mean to build a product that is coming from a startup. And so he kind of like has this definition of a startup that is a human institution designed to create a new product or service under extreme uncertainty. And that's pretty much what we are doing. Like, you have some traction, you have some users, you know that some users are using the product, but your goal is literally to double every 3, 6, or 9 months, depending how fast you are growing. And so to do that, you kind of need to put in place some way to kind of like iterate fast on your product and try to identify what helps with the growth. And so a good framework to look at it is this build, measure, and learn loop. So you can see that you kind of like not only build something because you think it's a good idea or because you think that it looks nice, but you build something because you have the goal to grow your audience and grow your user base. But so as soon as you build and you ship it, you need to be able to measure it, and you need to be able to understand which metric does it have a positive impact on, and which metrics is it hurting? And so to do that, you need to have some tools in place. So basically at the end of 2016, we kind of like decided to build our own target configuration service, which is our internal experimentation framework. So we used to use a company called LeanPlum before to do that, which is an A/B testing platform. I think earlier today there was a talk about Firebase remote config, and Firebase remote config is one way to basically achieve that. But we kind of like needed something a little bit more advanced. We needed to have something that enabled us to have like very fine, a very specific targeting, like something to enable us to use some very, I would say, LYFT proprietary criteria to target users. Like, we want to know, okay, is it somebody that took, for instance, a ride in the past 7 days? Or those kind of things are pretty hard to achieve if you are using a commercial or a third-party framework, or at least you can do it, but if you want to do that, you need to share a lot of information with them. So we kind of decided to use our own, to build our own platform. And also, so not only we can do heavy targeting, but after the fact, we are also able to do some very in-depth analysis and kind of like add some very custom metrics, and sometimes even add them like after the fact. Like, we run the experiment and we can like run some job on the data pipeline to actually gather the information after the fact, and kind of like create some potential metrics after we finish the experimentation. So That was a big argument to build our own tool, and that also enabled us to have some very advanced remote configuration management. So not only we have feature flags that we can easily remote control from the server, but we can also enable them for some very specific segments of our users. For instance, if we want to enable something only in one region, and a region can be a very LYFT defined metric, like we usually actually tend to organize region by airports here in North America. So it's not really a city, it's not really a state, which would be too big, but it's literally like a region around an airport. And so that's something that basically we can do with TCS. And we also added something that is pretty cool. When you are an Android engineer, we always like ship features, and sometimes we realize that either there is a typo, which actually is pretty bad if you ship something with a typo, but sometimes it's just that the string is not as accurate as it should be, or it's somebody from marketing comes and realize, oh, actually we should have said that instead. The problem is that the app is already live. So with TCS, we actually created some system that enable us to override the string from the string.xml file. So, and it actually works with localization. I think we are localized for something like 10 languages now. So we can literally override every single string, localized or not, in the application directly from TCS, so from the server, and automatically push those strings to the client. So yeah, so it's a pretty powerful tool, and pretty much everybody is using it at LYFT. All right.
Sweet. So we spent a lot of 2016 moving to a weekly release cadence, which meant that people could always plan and schedule ahead for their releases. Monday is always release day here at LYFT, and no matter how long this has been going for, that does not stop the daily and routine questions that my team constantly gets. Hey, who's the RM for this release? Do you think the app will be 100% tomorrow? I need to turn my feature on. These constant questions meant we needed to find a way to make sure that we were not a blocker for teams. So we built App Releases. App Releases is a tool that ensures that at any given time, there's one source of truth, and anyone can go to this site to get information on a release. We've gone all the way to adding in links to direct you to crashes in that single release, including what network issues may be coming up. But this really allows people to self-service. As we were growing as a company, we needed to make sure that not one team was blocking people from scaling. We wanted people to be able to make quick decisions about their experiments, and we wanted them to be able to push forward and plan for the future.
All right. So we are now in 2017, and we are 20 Android developers. So it's kind of like slowly growing, but there are more and more people working in the team. And so something that we run into is that at the end of the day, we are still people working on the client, and the client is talking to the server. And it's kind of like basically nothing new here. Like, we are Android engineers, we are focusing on the client, and we are depending on backend engineers. But the problem is that most of the time we are not necessarily iterating at the same speed, and we have a limited, for most of us at least, a pretty limited understanding of how the server actually works. And the only thing we know is basically the API and what the endpoint and the path to the endpoint is, and what is the shape or the form of the response from the backend. And so pretty soon we kind of like realize that we are a little bit like depending and kind of like stuck in our ability to iterate fast on the client, depending on the new endpoint to be ready or the new endpoint to be available. And so introducing Bubble, so the idea of the name is actually comes from working in your bubble. So being able to like work in isolation from the rest of the world. You are an Android engineer, you kind of like care about the client, and your understanding of the world outside of the client is basically the API and the endpoint. And so the idea of Bubble is to kind of like put itself between the client and the server as a proxy to not only inspect whatever is going on the wire between the client and the server, but also be able to potentially override some of the responses or even some of the requests if you want, and also potentially even create some mock endpoints. Like that you have an idea of what the backend engineer is working on. You guys agreed on what the API will look like. You can literally create a stub of a response and kind of like put it in your Bubble client that runs on your laptop, and you basically will have this kind of mock API endpoint that is ready for you to use, and you can build your feature without having to wait for the backend to be actually ready. So some of you are probably familiar with it. I mean, there are like multiple ways to implement it. The idea of like inspecting also what the API is sending is also something that you can achieve by using Charles or by using Stato or Flipper. If you guys are not familiar with those tools, I definitely recommend it to look at, but we kind of needed something a little bit more advanced there. And so the idea of Bubble is literally to have something that is very LYFT-centered, right? That kind of like provides some level of security that you might not always have if you are using third-party tools, and also that is heavily customizable. And so one thing that we can, for instance, do is to look at the API that is called for our analytics tracking and our analytics system, and kind of like extract the data that are sent for the analytics events and kind of like render them a nicer way. So that's like this kind of like custom behavior or features that we were able to implement. And so if we take a look at basically the features, is really that like you can literally simulate your old backend. So not only you can mock the response of endpoints that are still a work in progress, but you can override the response of existing backend, for instance, like add a fields or add like a dictionary to your JSON if you want. And you can also even do like some pretty advanced scripting communication scenario between the client and the server. And that also, as I said, provide like some level of diagnostics. Like if you see that there is something funky happening on your UI, you can potentially, like put a debug point in your code. But a good way to do that is to look at what the server is sending and kind of start with looking at the response of the server. And that's something that Bubble enables us to do very easily. So yeah, that's and you can also override. I was talking about TCS before, so all of those variables are sent basically on app start by TCS. You can potentially override that. So I was talking about the strings, for instance. You can potentially override the strings that are overridden by TCS directly using Bubble. So it's a pretty advanced tool, and it's definitely something super helpful that we needed at the time that was introduced to the team.
All right. So as I said before, we had one app, but this app was growing, and it was growing in size quickly. Excuse me. Engineers were adding more code, and it was actually becoming a concern that people would not be able to download our app over one network. So in 2017, we went on the big journey of splitting our app into two. The goal was that we would have one writer app and we would have one driver app, and therefore they wouldn't have to share the same profile in one app. The other thing we wanted to do is we also wanted to build out a more robust alpha and beta program. And since we were shipping weekly, we needed to make sure that we were getting as much testing as possible before going out to production. So since moving to this release cadence, it allowed teams to ship quickly and experiment quickly, but we needed to make sure that we built an organization that actually tested their features before we released them into the wild. Because growing also means sometimes you grow out of a process or you grow out of a tool that doesn't serve your customers in the best way any longer. And so this is the way our release schedule now works. Every Wednesday, 3 branches are cut. One for alpha, which is our running master. Beta is then built off of that master, and then release builds off the last beta build. This allows us to continue building and shipping at all times without a lapse. This system has worked for everything from code-wide code white freezes, as well as right now during the pandemic. Teams are always able to continue to merge to master, and a beta can always be cut for testing, but it does not mean that that release always needs to hit production. We're able to make clean changes, and we're able to quickly determine where that change was in case we run into a problem after hitting production. So during our building process, rider and driver branches are cut on the same schedules, and developers must push their changes to both apps.
So we are now in 2018. So we are 40 Android developers. So it's definitely a big team. I think at that point, I remember at the beginning, I tried to schedule a one-on-one with every single person joining the Android team, and I think at that point I basically gave up, and it's not possible. It's also the time where I actually moved from San Francisco to Seattle to join a satellite office. So it's definitely an interesting time, because you cannot really know or have like some FaceTime with everybody every week anymore. And so that's kind of like the organizational side of the things. But we have, when it comes to our CI, as I said, we talked about bug before. I think that part is pretty much covered. We are still heavily using Scoop, and we also integrated it with our dependency injection framework, which is Dagger 1 at the time, although we are planning the transition to Dagger 2. So that part is also pretty much covered. As I said, Bubble is also a good way to basically have a lot of redeem a lot of productivity to the engineers by enabling them to start working in isolation from the development of the backend. However, at that time, there is something that you notice if you kind of work in the office. Oops. If you work in the LYFT office, and you will notice that most of the time, like people have, or Android engineers have one or two devices sitting on their desktop, and they also have potentially an emulator running, and you kind of like realize that at the end of the day, LYFT, as Helen said, is now two applications, or two main applications: the rider application and the driver app. And so if you want to test your feature, if you are working on something that is even specific just to, let's say, the rider app, but you still need to simulate a flow, you still need to have a driver on the other end to basically reply to your ride request and kind of like accept your ride, basically. So you are now going into in-ride mode, and you can potentially test the feature you're working on. And so we kind of like found ourselves in this interesting situation where it's not very easy to test the driver app. And so one option that would have been pretty cool would have been to kind of like get those e-racing pro rig and kind of like retrofit the LYFT driver application on it. Unfortunately, that didn't happen, and instead we went with the command line solution. So we kind of created a command line tool that basically simulates the driver application. And so you can literally create a new driver on the staging platform. You can start going into what we call online mode. So when you are basically ready to accept ride request, and you can also accept ride request and then simulate the drive, the approach drive to basically get closer to a rider, and then accept the ride, pick up the person, etc., etc. And we also build the kind of like equivalent to simulate a rider if you are testing the driver application. And so this way you basically just have the app that you are working on and the feature that you are working on, whether it is driver or rider. And then you have this command line this command line interface tool that enables you to simulate all the action that you would need coming from the other application. So it's a pretty handy way to test, to debug, but also literally to work on your feature. And so, as I said, it's used for multiple commands. So create passenger, drivers, request a ride, pick up drivers. And we are actually, there is like a whole team, not necessarily dedicated to this specific tool, but working on tools, including Bubble that I talked about before. And so they are now like looking into basically executing some pretty complex flows that can combine multiple passenger and driver commands. But yeah, as I said, like we are a ride-sharing app, but there are, for instance, multiple modes. So if you want to test a specific mode, you can potentially simulate that via LYFT-CLI. And there are things that are only available in some areas, so it can be potentially tricky to spoof the GPS, for instance, to test. So all those things are basically made way simpler by this command line tool, this command line interface tool, and basically you save a lot of time when you develop thanks to the access to this tool. So 2019, so yeah, a little bit over a year ago, we are now 60 Android engineers. So you can see, looking at the graph, that there was a very significant increase. We kind of like realized that one thing that we are now facing is the fact that we are a lot of like third-party tools we have a limited control over. As I said, we kind of like started using LinPlum initially for our A/B testing as our A/B testing solution, and we kind of realized that that was potentially a better idea and a good investment of our time to build our own. And we kind of like followed this trend for every single third party, or not every single, but most of the third party SDK that we integrate. The problem with SDK, and that's very easy when you start to kind of like stuff your application with third party SDK, is that you have potentially a very limited understanding of what's happening inside the code that you add through your app. And it's not necessarily that the code is bad, but sometimes, there are side effects that are pretty impossible for the third-party developer to guess because they don't know your application very well. They don't know exactly what you are doing. And on your end, when you kind of run into like those kind of weird like ANRs that you are basically not able to debug, and the stack trace or the error message might not be super straightforward. On top of that, there is also something that probably happened to you if you integrate some third-party tools, is that sometimes they add permissions that you are not really aware of, and you often catch those only at the end when your app is being released in the wild, and somebody is like, "Wait, what are you guys asking for? Like access to, I don't know, the telephony permission, for instance." So we kind of realized that there are a lot of those type of tools that we should start building internally because we have the resources, right? You have 60 developers. We have a lot of things to work on, but we also have some spare time to work on those kind of projects. And so the bug reporting tool is that I'm presenting right now is a good example of that. We were using Instabug that basically was providing the same type of service, but for some reason was triggering some strange errors. And so after a while, we kind of like realized that it was probably just a good idea to build our own solution in-house and kind of like integrate it with all the tools that we are using, which is Jira, that Helen is going to talk to us a little bit about later. I think you're muted.
Wonderful. So at this time, we actually acquired a couple of different companies. We acquired companies that did bike, scooters, and transit. And through this acquisition, we were able to bring in a whole new mode of transportation for people. But this next hurdle also meant onboarding these new companies, not only to our systems and processes, but we also wanted to make sure that all the work that they had also done on their code base did not get lost, but we were able to still build the LYFT look into theirs. Each city requires the app to be formulated exactly for their city, so that there's special rules and regulations that we must follow in each one. And so we've built tooling that allows us to add and migrate to one code base, but we've also taken the time to really educate these new developers. We spent about a week doing onboarding here at LYFT. So there are all these classes that you go to, but we found ways to make it interactive so that people can onboard onto our new process, even if there is a time zone difference. And so the big day, we IPO'd, and this is when it's all worth it. The 3 a.m. pager duty pings, the hot fix on Friday, the dumpster fire that sometimes meant you had to call in a principal developer to fix. This was all the hard work that we have been working towards. Also, probably the earliest I've woken up for a work event ever. But with all the great things that come with being an IPO companies, there are also all the downfalls. Investors want to make sure that the change that you're making is not going to negatively affect production. So one of the big areas that we actually had to quickly go and fix was our cherry picks. People always want to get their cherry pick in. And before this, it was like, oh, your UI is off by one. Go ahead, cherry pick it in. Oh, your experiment didn't make the cut. This was way before we had TCS. Sure, let's cherry pick it in. People were asking me for cherry picks in bathrooms. There was no way to really make sure that there was one system to pulling this in. And we just lacked a consistency and transparency of why a cherry pick was actually really needed. And so we went around and we built a standard for what is allowed for a cherry pick during our beta process. And we also made sure to build a system that allowed one intake. So a release manager could pick a cherry pick, look at all this information that they needed, and make sure that this was really the cherry pick they needed. By setting these standards, we were able to make sure that teams understood from the start what kind of changes were really accepted. The other problem that we were also running into is we just didn't have one source of truth. With over 5,000 people that needed to prepare for every single release every single week, with over 50 plus teams and their roadmaps, and with all these places that people were putting in updates, we needed one source of truth. And the one source of truth at LYFT just happened to be Jira. So we built a system that allowed people to be able to use Jira to plan for their features ahead of time. Features were often shipping without meeting minimum LYFT-wide quality standards. And not because people didn't care, but people just didn't know because we've not set those things out. When our team became big, it very much quickly ran up on us. And so Launch Tracker was built. Launch Tracker was going to be the one source of truth for everything. One roadmap item was going to be one Jira epic, and each epic was a standard format that allowed information to be generated quickly. And then that way we were able to build flexible roadmaps that created reports that anyone at any given time could see. That way teams could decide, hey, maybe I didn't get everything done and ready for this release. I'll wait for the next one. It also allowed our support team to make sure that they understood what features were actually going out so that when they did reach production, they were not stumped when someone called in and said, hey, how come now I can give scheduled rides? Plus, this also enabled the release team to make a fair assessment of the features that were going in. This doesn't always happen. This doesn't happen with Google, but we started seeing it a lot more with Apple, who wanted heads up on these features that we were putting out. And so we wanted to make sure that we were able to safely roll out our features and keep to our weekly cadence.
Cool. So today we are something like 7,500 engineers. So it's definitely a big team at that point. And so if we can basically summarize the thing we talked about. Oops. I'll let you jump in, Helen.
All right. Probably the biggest thing that I learned throughout this is sometimes process changes can happen at different levels of the company. We made a lot of process changes very quickly on the mobile team. And as you can see at the end, we actually started having to roll those out for the entire company. So piloting changes with small teams was really helpful for us, gave us time to fully understand problems and to fix those and build exceptions if needed. The other thing is you've seen is sometimes you do need to use third-party tools as you're growing, before you start building your own in-house. This allows you to determine what really works for you and not spend so much time building something that's too customized yet.
Yeah, and it's also interesting to identify your needs along the way. So there are a lot of tools that we didn't really need at the very beginning because, people are kind of like crafty and they can like figure out things. But as your team grow and you have like people who come and don't necessarily have a lot of like tribal knowledge, like those tools can be super helpful, and you can literally like divide the time to build a feature by like several fold just by providing the right tools at the right time. So identifying your needs along the way is very important, and potentially every 3 to 6 months, it's good to do a quick checkup and see like what are the challenges that your developers are running into when they are developing new features, and try to build the tools that can speed up those developments. And then the counterpart of that is that, yeah, you should anticipate, but you should not anticipate too far ahead either. Like if, for instance, you only have like 2 people working on the app, like switching to Buck might not be a really good idea, because it's going to ask a lot of support and a lot of like effort to make sure that it works. It's not necessarily like the most seamless build system to use, I would say. And so, yeah, basically you probably want to kind of like stay as much as possible into the existing most common and most popular tools. But it's always good to keep in mind that at some point you're going to need probably some tools that you don't have today. And that's the end. So thank you very much to both of you. I scheduled my my office hours, so if you guys want to chat with me, I don't know if Helen, you did the same, but yeah, if you guys want to chat with us, feel free to reach out. And we actually have I don't know how long we have, but we have like a few questions, so we're gonna try to go through them super quick. The first one, yeah, from RJ Hamilton. So yeah, I think it's a very good question. Honestly, Lyft is a very, very decentralized organization, which kind of like led us to sometimes have to realize that several people were trying to solve potentially the same problem with different approach. And that sounds a little bit messy, but that was actually very successful at Lyft. Like, it's okay if sometimes several people try to tackle the same thing, as long as they talk early enough and they kind of like adjust their roadmap. And so one example that we are doing, and Helen can also complete the answer, is that every Monday we used to have, or we still have, what we call the feature syncs, where basically a lot of like Android engineers come together and they kind of like present the project they're working on. And it's a little bit of both, like you kind of like are aware what other people are doing. So when you need to build something, you're like, oh, I can do this, or I can reuse that. And you also get some feedback from developers who potentially run into the same issues, and they can tell you, oh, look into this feature or look into this to kind of like implement your feature. So yeah, gathering every week as many Android engineers as possible, and kind of like having them presenting their features is a good way to address that. And then you wanna add something?
Yeah, I think probably the thing is we have a really robust onboarding process when teams come on. You get usually a mobile mentor that has been here for quite a bit of time, so that we do have a mentorship program. We've built a lot of very interactive education that not only can you do like in a group, but you can also do by yourself. So we really tried very hard so that from the start, people are able to really get going very quickly.
Cool. And yeah, okay, we have more time only for one last question. So I'm okay. Okay, somebody bumped. Yeah, thought between Gradle versus Buck. So actually, to be very honest, we are about to transition to another build system. We are planning on using Bazel, which is kind of like the open source version of Blaze that is the equivalent of Buck, but for Google. So it's kind of like the internal build system at Google. That kind of like deserves its own talk. Actually, if you are interested, Artem Zinatulin, you can basically look up Lyft and Bazel on YouTube, and he already gave a few talk about it, and he's kind of like our in-house expert. But to answer the question, I would say, yeah, I think Gradle has caught up. I'm not an expert on the build system, but I think Gradle today offers you like most of the features you need to build a pretty decently sized application. And if it doesn't fit your need, it's definitely worth like investigating before you make the jump to go and start using Gradle, because it's honestly not a seamless transition, and that's definitely going to require, at least at the beginning, a lot of resources to put it in place and to maintain it. So I would say try to stay on Gradle as much as possible, except if you hire an expert in Buck or in Bazel and is interested in doing the transition. All right. Well, thank you so much, everybody. And yeah, feel free to reach out to us if you want to chat more. Thank you.
Thank you.